everyone, and welcome. It is Wednesday, the 21st of August. It's the third Wednesday of the week. That means it's Rock ID time. So, if you don't know, we do have a Patreon page where if you have a sample that you'd like to have our crew look at, you can sign up as a monthly supporter for $25 on Patreon. You get a lot of extra benefits. One of them is the Rock ID and a Rock ID video most of the time. We're lucky we have 4 videos tonight, but we're super fortunate to have our staff geologist back with us, Mike Kelly. So Mike is going to give us some we're all going to give you educated information, but Mike has the paperwork and the education to stand behind. I stand confident with what he says. So let's get right into the videos. We have 4 of them today. We're going to move through them pretty quickly. So this first one is from, they named themselves Rockhound supporter. So
now, it just reminds me of the Earth check ones, but not exactly called like Diagen or Digenite. I think that's what you'll call it. But I've never seen anything like this before. And the only reason why I was doing a video, I was looking at chondrules and stuff. And I noticed
this is an exposed area that shows the matrix containing what he believes are chondrules.
like even some of them fell out of here over time after I dremeled it. But I've noticed there's like little glimmers of metal, stuff like that. This looks like chondrules. And then I have like there's these things, they look like veins on this thing.
This specimen was found in Henderson, which is in East Texas, approximately between Dallas-Fort Worth area and Shreveport, Louisiana. Supposedly it was found near a crater. Now, there are 3 craters in the Met Bowl documented for Texas. That's Odessa, Sierra Madre, and Marquise, as detailed on this map. I believe the find is outside the ejecta field for the closest, which would be Marquise.
Just never really seen anything like this before. No, we don't have nothing like this out here. You know, I look and study like all kinds of rocks and minerals and stuff like that. You know, for a very long time, I have like constant books on, and I've never seen anything like this but Erd check. The Erd check of chondrites. Now there is metal in it too. Now notice when I get this with like a magnifying glass. See, that's a better view. There's like shimmers of metal.
All right, guys, that was our first submission. And we are open for anyone's feedback. I noticed there was a few terms thrown out that we may want to mention: achondrite, diagenite, chondrules, veins. Did anyone see any chondrules in there, especially in the dremeled area?
I didn't see anything that stuck out to me as meteoritic. I'm obviously not a geologist, so I couldn't tell you what type of rock that is. It would have been nice to see like a cut face instead of just a little bit ground off the top, but I didn't see anything that stood out to me as being suspiciously meteoritic.
All right. Thank you, Chris. I'll look for another raised hand or someone pointing to the camera. I will mention one thing. He likened it to herb checks, and I appreciate that. That helps me narrow down what you're seeing and what you're paying attention to, the color, the texture-ish. So hopefully seeing those side by side on the same screen was evident that they're really not that similar. Allison, Prairie Girl Rocks, what you got for us?
It is not a terrible meteor wrong. Because the one thing that it does have going for it is its texture. It's not porous, it's not rough. It is, microcrystalline of some sort. And so, texturally it's not terribly far off. So kudos to our finder here. That's not a bad looking meteor wrong.
You're awesome. We love you.
Well,
Dave Pinsky, and then we're going to go to Mike Kelly.
Yeah, I noticed on the outside, it looked like it had a layer of weathering that may have helped give it that appearance of the Urchech meteorite. Because on the Urchech, you have some of the similar colors, but the interior, when I saw that, didn't really look much like Urchech. And so that's one of the things that I had noticed. But yeah, it's always good to pick up a rock that doesn't look like it belongs. And well, it's rare that it would be a meteorite, but sometimes you find some interesting rocks that might be interesting.
Well said, man. I appreciate that. Yeah, because if it looks out of the norm, hey, it may be something. It may be something terrestrial, but it may be something extraterrestrial. Odds are terrestrial, but there was a mention of in that Dremmold area seeing some metallic shimmers. I didn't necessarily see them. Mike, we had a conversation about this earlier, and you said you might know what the submitter was talking about. So over to you, Matt.
Certainly.
Mike?
So, yeah, hopefully everyone can hear me okay.
Yep.
First of all, Dave, spot on with what I was thinking with you. You know, exterior, I think, is why he was going, hey, it looks like Urchech. Again, Urchech is crustless. It's been on the ground for a long time. It's weathered. You'll get similar weathering effects on earth rocks. And so the exterior look is similar. I agree. It probably stops about there because, again, the shiny metallic bits you're seeing in there, I have a feeling that this is a schist, which is a metamorphic rock. He mentioned there is some veining in there. What I noticed is kind of cutting across the top part of where he dremeled it. It looks like there's kind of a compressed white vein line in there. Again, that's something you wouldn't really see in veining in meteorites. The veining in meteorites is melt, right? And so it's dark in nature. It's a melt. That looked whitish and light, which makes me think it's a loosely foliated schist. So a lot of schists, if you just look at lots of pictures of schists online, some of them have great banding to them, a lot of foliation, a lot of lines and striations. Some of them are weakly foliated, which means that they don't really, they haven't crushed all the layers from the original rocks they were formed out of. And so they're more kind of uniform in texture. That kind of seemed a little more uniform texture with just a couple bands to me. And what I had mentioned to you, Topher, was, yeah, it looked metallic, but again, it's hard in a video, but there's metal and then there's metallic luster. So a lot of minerals have metallic luster. So if you take a piece of hematite and you shine it up or even have a clean cut face, it'll look like it's solid metal, even though there's no metal to it. It's all oxides. I have a feeling that those are either oxides or possibly even bits of mica or some other minerals that you commonly find in schists that have a high metallic luster to them, because they seem to be in all different orientations and they seem small and needly. Where in a meteorite, right, with metal in a chondrite, it would typically be blobs or globules. You wouldn't see like a fine interspersing of needly grains, which seem to reflect off of there. So that's my thoughts on that one.
Fantastic, man. Welcome back. We love you on the crew and we love your information. We love you even more as a person, though. Now, we also have Pat. You don't need to make a comment on every single one, but if there was something that you wanted to point out, I want to also give props to Pat because for years, Pat was the main guy running and seeing most of the pictures. Don't correct me, I'm saying this even if it's not true. He was the guy responsible for looking at all the pictures on is it a meteorite or MeteorWRONG? Either one of those groups or both of those groups, I don't care. It was a lot of pictures over many years dealing with a lot of Rockhounders. So he is very well versed in MeteorWRONGs and meteorites. So Pat, do you have anything to add to this sample?
Yeah, so I agree with Michael that it does look metamorphic. It probably started out igneous because metamorphic are just rocks that have changed. And one thing we want to be really clear about with our rock hounding friends is igneous rocks or metamorphic rocks won't show chondrules. Urchech is an igneous rock from very, very early in the formation of our planetary disk, but you won't find chondrules in achondrites.
Absolutely. I'm glad you put a bullet point on that one. I kind of hinted at the beginning, but yeah, was that it? Okay, yeah, good. So when you're looking at a sample and you theorize that it's a diagonite, or you theorize that it's a ungrouped achondrite or any achondrite, if it's an achondrite, there's no chondrules. So if you're trying to prove it's an achondrite by looking for chondrules, you're kind of fighting yourself in the dark. So I agree with everyone's interpretations and opinions. Thank you very much. We are going on to video submission number 2. This is a submission from a reoccurring submitter, which we really appreciate. This is from Ralph in Germany, and he believes he has a what could be a lunar meteorite, or looks to him like a lunar meteor on the outside. So here we go. Thanks, Ralph.
Hello, this is my stone. It's unmagnetic. Streak test is clean. Has this brownish crust and this grayish crust. From the grayish crust, it goes here down the flowing. You can see. Yes. Yes. Here, what my little looking, and this grayish crust. The shadow's blades concerned me be a little bit more. No metal, but crust. I bought it for 10 euros with other stones together in a second-hand shop. Yes, that's it. I hope you could see everything I see, would like to see. Okay, it looks like the NWA 4463 from the crust. Similar to, okay, thanks and bye-bye.
Thanks, Ralph. I'm really appreciative. I love the way he says, I hope I am showing you everything I'm seeing or think I'm seeing, or that was really cool. Do we have people with opinions or feedback on this rock? Allison, would you love to start it off?
I would, thank you.
By the way, I'm going to interrupt you for a second. I'm going to interject, sorry. Prairie Girl Rocks. Allison has her own YouTube channel. She does rock hounding shows every Wednesday. You can join her live. She's fantastic. She's a very kind, loving person, and her community is awesome. So definitely pay her YouTube channel some love. Now, go to you.
Awesome. Thank you, Topher. Again, this is a good looking MeteorWRONG. These samples are really good this week. I'm enjoying this. The two things that I see in this particular sample that are bothering me are that end right there that we have the still of in the bottom left. If I'm not mistaken, I am seeing some layering in there. And I do think that I see that again later. And also later in the video, the fractures, yep, there along the top of the still in the bottom left, the fractures just don't look right to me.
Rolf even commented in his video that those angles right there that you're pointing out, he didn't like them either.
Yeah, they don't look good to me. Anyway, that's what I have, and I'm curious to hear what Mike Kelly has to say about this.
You're awesome. Thank you so much for your help. Appreciate it. Did anyone else see some features that they wanted to talk about? You may not have to know everything about it. And here's an example of someone who doesn't know anything about anything. Mr. Steven Amera. No, my buddy Steven, how are you, man?
Good. How are you? Can you hear me okay?
We can hear you perfectly. Let me give you a worthy introduction, because you're not just a nobody, and you're not just a rockounder, and you're not just a detectorist. You are a very successful all of the above, including the finder of the largest meteorite, second largest meteorite ever recovered in the state of Massachusetts. And it was through a decade of work. So you know the blood, sweat, and tears that go into finding and recovering these potential samples. We'd love your feedback.
Thank you so much for that introduction, man. So the thing that stands out the most to me is the conchoidal fractures. I don't think that's typically present in meteorites. It's kind of like a igneous rock type thing, but it almost to me looks like chert, if I had to guess. But that's my comment.
Okay.
To me, it doesn't look meteoritic.
Appreciate your feedback. You're one of the guys that when I go to Tucson and we're digging through a box after box after box of unclassified meteorites, you're the one that is able to pull out a stone, give it to the Moroccan Algerian dealer and say, you may want to take a look at this one. Don't sell it as a meteorite. And 9 times out of 10, they listen to you immediately. So thank you for your feedback, and thanks for joining us, buddy.
You're welcome. Thank you for having me.
No problem, man. All right, we'll go right to Mike then.
Okay. Yeah, so on this one, starting off on that gray area, what I noticed is what he was describing as gray crusts. It sits proud of the other crust surface that he's saying has flow to it. And so crust, you wouldn't have layering to it, like Allison is saying. You know, if it's crust and it moves from one part of a stone to another, it would smoothly transition because it's a function of melt. The other thing that I keyed in on is where he crosses the top flat large area. All of those lines are kind of crisscrossing and zigzagged, whereas with flow, you know, one flow would go over the top of the other smoothly, and you basically erase, you know, a former flow if you were to flow new crust over it. That's a texture I associate with weathered sedimentary rocks. Stephen had mentioned chert. So limestone and other rocks like that are susceptible to weathering will often have a karstic type texture to them, and that's a feature that I associate with those.
I'm sorry.
What was that?
A what kind of texture? I'm sorry.
A karstic. Karst is like a limestone or any type of carbonate based. So I have a feeling that this has a lot of carbonate bonding it together. And what you're seeing on that top is the erosion, especially if it's in a slightly acidic environment. So the top gets weathered in that very stippled kind of pin-like pattern, whereas crust would flow and kind of be like a thick liquid blown over the surface. You wouldn't get kind of hard corners to each little individual channel. And again, yeah, I second, you know, you don't really see conchoidal fracture in meteorites. It's not a thing. They're not glassy. In nature or brittle in nature like that to get conchoidal fracture.
What do you feel about? I'm going to lose it. I want to go back 5 frames. What do you think about like these lines right here? I don't know if you can see my pointer.
So I think I think that was part of where it broke off. And so again, if you break the rock off and it doesn't necessarily break off clean, or there's shear going on when it's hit, you'll get shear lines almost like you would see kind of in a slick and slide type effect, where the mineral grains are rubbing against each other as they slide past. So yeah, I think he's got a something with a lot of carbonate bonding it, and it's probably sedimentary, and it's like a siltstone or a mudstone.
Fantastic. We love you, man. Thank you so much for your input. I want to just ask one quick question. And then I want to throw it over to Pat for whatever he has. Plus, I have a question for him. This right here, do we all agree 100% that this light gray material on the outside of the rock is 100% terrestrial earth contamination.
Yes.
We all agree. Okay.
Yeah.
Thank you.
Yes.
Pat, you're more of a chondral and internal guy. I put this up here just in case it would help you, but you're willing to talk about anything.
Yeah. Okay. So I picked up on the conchoidal fractures too, and conchoidal fractures are a special way of very, very fine grained rocks or glass fracturing. And so when we see that, it shows us that it's a very, very fine grained material. I was gonna say more basaltic looking, but I think Michael's comments about carbonates in there is point on. Also, the stuff that he was seeing on top and describing as crust, that stippled sort of effect, Mike's analysis of that is spot on, that is essentially soil or water etching. And if you contrast the top surface of the rock with the bottom surface, you can see the bottom surface is fresher. So yeah, I agree, this is not a meteorite, it's some sort of very fine grained earth rock. We also have to remember that Earth is formed out of the same things that our meteorites are formed from, either dust or chondritic meteorites differentiating. So Earth rocks are not super different in that it's, a differentiated body. That's all I have. Thanks.
Thank you, man. Appreciate it. If you look at this, I also want to point out the fact that I don't know if Rolf is saying he thinks it's lunar or it appears to be like the other lunar, but when we look inside the interior here, I'm not seeing any chondrules, which is good because a lunar is an achondrite. But when he was moving it around in the video, you could see a glassy sheen on it that is not going to be there except on a highly polished sample from the moon. You're going to see brecciation, melting. You're going to see the regolith all pushed together. You're going to see something besides what we're seeing here, which is more homogeneous than would ever be in a lunar sample. So that's my 2 cents. And I agree with everyone. We have another meteor wrong here. I need 13 seconds. This is awesome, guys. You're doing great. Thank you. All right, here's a video number 3 for the day. Number 3, Megan Murphy. I have to say this is probably the best. We get a lot of great submissions. This is probably one of the best voiced over submissions. So enjoy the voiceover information and look for key things that you want to talk about.
Topher, the name's Morgan Murphy.
I am so sorry. I have a little friggin' logo over there and I can't see. Morgan Murphy, thank you so much for correcting me.
Hi, Topher. It's Morgan from Virginia Beach. I have a rock I would love for you and your team to take a look at and tell me what you think. This rock was found in Suffolk, Virginia, which is about an hour away from Virginia Beach, where our farm is located. We have 1,000 acres that is known to be in the strewn field of the Chesapeake Bay impact crater. So we're finding tons of these guys, and they're very unique looking, definitely different than our usual rock pounding experience out in Virginia. What's really catching my eye to these is how magnetic they are. And I even cut a piece just to see what the inside could look like, and it looks to be solid metal. Very unique looking.
I have to interrupt for a second. The background noise, the space agey sound effects, I absolutely love. It's an artifact of me removing all the wind that was blowing, and it left this background ghosty cosmic noise that really is awesome.
Very, very good. Thank you for taking the time to look. I hope that you guys have a great day.
Thank you very much, Megan. I appreciate that. I also appreciate the fact that she went a little overboard.
Hi,
Which is,
Topher.
oops.
It's Morgan from Virginia
Hi,
Beach.
it's Morgan. I had it right the first time. Dang it, Morgan. I'm sorry. I know rocks. I'm sorry. I also want to thank her because she went overboard and actually sent a copy, sent one to me for me to check out, and it's portrayed very accurately on the video. I did want to make a comment about the magnetic susceptibility because she mentioned it was highly magnetic, and then we really didn't see the magnet jump onto the piece. So I have my rare earth magnet, and I have her sample here, and it's not highly magnetic. It shouldn't fall off that easy if it's highly magnetic. We should see it jump, and I don't have any magnetic meteorites here. So, but yeah, that is not a highly magnetic sample. I'm going to pass it around the horn for people with feedback, including Dave Pinsky.
Yeah, it to me that looks like classic magnetite, the stuff that is really, really common, but it's probably the most mistaken rock for a meteorite because it does stick to a magnet. Some are a little bit more magnetic than others. Some of them actually are magnetic themselves, where you can put a little pin next to it and it'll stick right to it. But this is what you usually find when you go hunting for meteorites and it sticks to the magnet. When you look inside, and if you scrape off a little bit, it's going to look the same. Now, she had mentioned it looks metallic. A metallic look should be more like what the magnet looks like when you scrape off an edge. It doesn't have that iron look to it. It just looks the same as the surface area.
It didn't have a mirror metal like sheen.
Yes, that's what I meant. And so literally you go to the beach, drag a magnet across the sand, and you're going to get tiny little grains of sand that look like that, only they're really tiny and they stick right to a magnet. That's where all the iron that's on the surface of the earth is in that form of a iron oxide. The metallic iron is in our core that is churning and creating a magnetic field that protects us from radiation. But that is, to me, if I hear something different, I'll be happy to change my opinion. But that looks like classic magnetite.
Oh, I saw a bunch of heads in the gallery shaking along with you, including Allison. So let's go right to her.
Yes, I was nodding along. Well said, Dave. And thank you, Morgan, for your submission here. This is a good one. It is very, very common. It is something I find all over when I'm out rock hounding. The things that I dislike about this stone visually when I'm going for a meteorite ID are the pits and pores that are all throughout the outside and the inside of that rock. And like Dave said, the color.
Mm-hmm. And so I'll agree with you, and I'll even take it one step further. What I don't like about the pits on the outside is how uniformly round they are. Like, you may get a little bit of softer material that weathers out, and it may be a round circle, but it's not going to happen 98% of the time of all the things on your sample. They're not all going to weather out in round circles. And that's kind of what we're seeing. I'm being hyperbolistic about it, but you guys get me. Mike?
Sure. And to an untrained eye, you may jump and say, oh, that kind of looks like chondrules because it's round. But again, we don't get chondrules in iron meteorites. So.
Yeah, and this one, thank you. This one does not have enough metal in it to me to be anything other than an LL, which is the lowest, besides the non-metallic meteorites. It's the lowest metal containing meteorite there is, basically. Mike Kelly, you had a chance to look at this one last night.
Yeah, certainly. So my thinking on this one is it's actually weathered slag. So there's potential that it is magnetite. The one thing that throws me off from thinking that was when you put your magnet on your piece, Topher, magnetite would be uniform. It would all be highly magnetic. So the fact that she's got a piece that has a decent magnetism on hers, it looks like, but the piece you have is variable and low, makes me think it's likely slag, because slag will have variability in its magnetism. Magnetite, pretty much, it's all highly, it's going to attract the magnet. One thing she could do is she could do a streak test on it, right? Magnetite, you're going to get a dark black, solid, heavy streak on a piece of unglazed porcelain, on a cut face or a scoured face like she has there. Slag, usually you'll get a little bit of a gray streak, but it's going to be a lot lighter. It's not going to be as heavy as a magnetite. So it's a way for her to also go ahead and get some more out of doing some basic tests for field study. So yeah, I'm thinking with the vesicles in there, like you're saying, and the uniform black nature that is not metallic, but it's not metal, but has metallic kind of luster to it. That I'm going with slag.
Okay. I thank you very much. I also, there was a good freeze frame right there. You can see these holes. It's pot marked with holes, and we mentioned vesicles can be found in meteorites, but they're very rare. They're usually small. They're very rare. I'll say it again. They're very rare. We are the collectors of rare meteorites. We are a consortium of a lot of years of collecting. So really, we are collecting the oddities, and we're showing off ones that have vesicles. That's not the 90% of the rocks that are going to fall to Earth. We're talking about the rarest of the rare of the rare, and we're showing the rare features because we're trying to show off. That's not what you should be looking for in your samples on a daily basis as you walk out in your strewn field or hunting ground. Pat, did you have something, or do I have another? Pat, do you have something to add?
No, I think the crew really hit it all there. So yeah, it's the vesicles. This vaguely looks like a chondrite meteorite, but the round features on this one, I think, are filled in vesicles. They're very large, or really too large to be chondrules. And note the very even color of the dark gray material. So yeah, the crew's got this one right.
This is a
Topher, I had one more thought.
Yeah, go for it.
One thing she mentioned in the video that I thought would be good for the crew and everybody in general is she mentioned the Chesapeake Bay impact structure. That was a super huge impact. And one of the interesting things is you wouldn't find meteorites associated with a impact that large. As impacts get bigger and bigger, basically the entire impactor vaporizes, just like Chicxulub that eliminated the dinosaurs. So yeah, it's interesting. She'd be relatively close to the Chesapeake Bay impact area, but the only thing that's found that's meteorite related from that structure is Padiasites, tektites out in College Station, Texas, which shows how far that ejecta was thrown. But yeah, there's no meteorites associated with that impact.
Awesome. Thank you. Crew, I really appreciate all your help on this. I fully agree that it's not a meteorite. I'm not 100% sure. I never want to disagree with anyone on the crew. I'm not 100% sure. What the first thing we mentioned was what?
Potentially magnetite.
Magnetite. Thank you. I don't know if it's that. I guess I haven't seen enough slag that looks like this to say that it's slag, but I will 100% say that this is not worth spending any more time or money investigating scientifically outside the cutting it open, polishing it up, those type of things, street tests, home tests, but definitely not a sample that we think has validity passing on the food chain to the scientists who would use expensive equipment to go the next round. So that was my summary on that. All right, this is a video submission from Kelly, a new Rockhound supporter on Patreon. So Kelly, thank you very much. I hope you get some useful information out of this. Here we go.
Hi, my name is Kelly Meadows. I found this meteorite in Brunswick, Georgia, 2012. Started research in 2024. When confirmed, this rarity should set new records for the state. After cleaning dirt, shells, and rust, it was treated and it retains its deep purple black color, as you see now. After passing all the preliminary tests, the magnet, the scratch, the irregular shape, she weighed in at 2.0 pounds and has a unique and distinctive smell. Now to the good stuff, the point of entry, the fusion crust. Here we have a fully involved fusion crust. As you see, it's well-rounded. It has shocked veins. It has 3 rippling waves showing the plasmatic friction created during descent. A colorful display of grains fused to the surface as if it was shellacked on. Since becoming terrestrial, it has retained a weathered brown surface. Flow lines have been captured in this area right here. You probably need close-up photographs to view that, but you can see spider webbish to drippy looking stuff on it. The following is specific to pallasites only. Shallow ragmolips, I stick my finger in one, or fingerprints as they're referred to. Large vascals or holes permeate the entire rock, front, back, sides, everywhere. That was to allow gas to escape during the cooling. During thermal ablation, broken top occurred, exposing a molten matrix of metal and silicates. This 50-50 mix shows opaline crystals coursing through the upper half, super dark green, almost black, with some other yellow gold and brown copper. I will do a test here with my pointer, showing the metal in certain areas. None on the top, just total silicates. Total 234. During the inspection of a certain photo, I have discovered an enigmatic anomaly that just defies logic. This may be more important than the rock itself. I predict this will soon be the most and rarest studied meteorite to date, and I need your help.
So these are pictures that show an area that caught his interest, and there was some letters that he was seeing inscribed inside the meteorite. So I'm basically just going to ignore this whole anomaly, because if aliens were able to send messages to Earth, I doubt they're going to be so microscopic that they'd have to inscribe that inside a rock that hopefully we'll be able to see with a microscope from the right angle. I think that's 100% pareidolia of seeing a message inside a rock, and that's where we're going to leave it on that subject. I would like to open up the conversation to anyone else who would like to talk about this from a meteor right or meteor wrong, or any of the statements made. It was an engrossing narrative full of misinformation, and that's why I had to put the warning on the bottom, because I don't want anyone happening upon my channel watching 2 minutes of that and thinking that that's what we're doing here. So let's go ahead and send it over to, oh wow, I've never seen this hand up on a rock ID before. My beautiful wife, Sue, what do you have for us?
Thanks, Topher. I know I don't normally raise my hand because I'm not usually very confident, but I am really confident that this is not a meteorite. However, I just did want to there were a lot of features that were misidentified, but I did want to give props to this submitter. I think you used the word engrossing. He was one of the better presenters that we've had from the Rockhound support tier on Patreon. His voice was really clear. He obviously had notes. He was really organized. We have a lot of people that you can't hear them. They're kind of mumbling, almost talking to themselves sometimes. And that was not the case. So I thought it's not a meteorite, but it was a great video, and I would just suggest to this person keep looking. But yeah, I wouldn't spend too much more time on this one.
Awesome. Thank you so much. And wow, we have a new Rockounder in the house. Allison, I see your hand up. Well, I'm getting bored of hearing you. I'm joking. Go for it. What do you have?
And I'm gonna again approach this from a Rockhounders point of view, but also a meteorite collector's point of view. I have never ever in my life heard of a purple palisite. It'd be cool, but I've never heard of it. And that was one of the statements made in the very beginning, was that this maintained a purple color. Again, no purple pallasites. The next thing that just really jumped out to me, other than that bit of fusion crust that's on the back, farther back part of the meteorite rather than the forward part of the meteorite. I'm gonna let maybe somebody else discuss that, but there's no gas bubbles in palisite meteorites. Gas bubbles in meteorites is again exceptionally rare, and claiming that you have gas bubbles throughout your rock is just more proof that it's an earth rock rather than a space rock. So that's what I have for now.
Thank you so much. I agree with you 100%. That's why I included this picture. This is one of the largest main masses of a meteorite that I've ever seen. Don't look in the lower left-hand corner for the hint. I see everyone's eyes going down there. What meteorite is this? Anyone know? This is the main mass of Fukang. It does say China right there, so you could have. So yeah, this is an example of a massive palisite. You're not going to see any bubbles. This is a solid item full of iron, nickel iron metal, and olivines. 50% ratio, like he said. Thank you, Allison. Dave Pinsky, over to you.
Yeah, first I just want to compliment him on the photographing. I do photography. The lighting and the focus and everything was really, really well done. Now I agree that it's not a meteorite. I think Allison beautifully kind of put it that way. But what I kind of think it is slag of some sort.
It is.
It looks very much like slag. And again, no vesicles like that in any kind of meteorite, and it's all one color pretty much. The slag part, the colors that he was seeing, the purples and such, are probably the impurities of whatever is in that waste from the smelting or whatever it is. I don't know. It looks a little glassy, but yes. I don't know.
Thank you very much. I want to, what he's demonstrating right now is exactly what you were talking about. It being metallic in some places and silicates in the other, and you said it was slag. Slag that's poured out will have metal going to the bottom and flowing, giving that dynamic entry look that he was talking about. It'll also cause air bubbles to come up into your item. So you will have an item that has air bubbles on one side and potentially, well, I can't find a picture of it, potentially fusion crust or solid or silicates on one side. That to me shows it is a piece of slag, especially with all of the vesicles, the glassy reflective shiny interior of the bubbles of the vesicles is an absolute rock bottom no. But I did see, I was trying to look for one frame on this where I could pause it, just like we showed last week or 2 weeks ago, or in a rock ID. We could literally see a hash grain where the slag material was poured out onto a cooling rack, and the hash grain of the rack was instilled in the slag piece. And you guys probably can't see it, but I was looking at this the other night, and right in here, I'm hoping Kelly will take a look and see if he sees what I was seeing, which was an obvious hash mark of a surface that it was poured into. That's what I was seeing. I could be wrong, but I'm going to throw it over to Pat for, I'm sorry, we didn't have Mike go yet. Do we need Mike?
Well, I wanted to say one thing first, that Hobo in the comments mentioned another possibility, that it could be something called gothite. So we'll see what Mike says.
Okay, thank you. Appreciate it. Mike?
So I'm thinking it's slag too, and I got my training piece of slag out that I use for presentations, and like you were saying, smooth on one side. So yeah, you can really get a good fox looking crust on poured slag, like this surface here. It's pretty convincing, but just like Kelly's piece, as you roll this piece around, it's classic slag. It's very glassy on the inside. There's very sharp corners. There's very vesicular bubbles. Hobo Minerals had mentioned gotholite, which is an iron oxide. It is oftentimes botryoidal or migdal. And the way that the vesicles were in those pieces makes me think it's more likely slag than gotholite. You would have a very black, shiny texture to it. Again, as he's describing, like the purple colors and hues and things like that, I'm with Dave on that. That's impurities and things like that coming out of slag. So the one thing I did want to also mention is, you pick this stuff up, first thing I'm doing after the hangout is going and washing my hands off. There's all sorts of nasty things in slag. It's a very good instrumental training piece to have something like this around, because it is a very common MeteorWRONG. But yeah, my take is foundry slag.
Yeah. Fantastic. I really appreciate you approaching that from not only a geology, the crew I'm talking to in general, the global view. Glad you were able to approach that from a rock counting point of view, from a scientific point of view, from I actually have an example of it in my hand. Now, it's not going to look 100% identical, because it wasn't 100% identical slag waste from the same process. It's going to look different, but god dang it looks close, you know. And it's really good to have those examples. Crew, Pat, am I cutting you off? Did you have anything?
I would like to comment very briefly on this one. So over the last 15 years on Meteorite or MeteorWRONG, it isn't a meteorite, the most common MeteorWRONG we get is smelting slag. And this one, I think, is a perfect example of that. It shows vesicles. And also, you notice the vesicles weren't spherical. They were kind of blobby and flowed and elongated and stuff. Uneven magnetic attraction is super common with slag. And some of the very, very old slag that was made out in the woods in a clay oven where they found the iron ore contains a lot of metal. Some of it even looks, you know, bencubanite sort of little blobs. The iridescent appearance on the surface is very diagnostic of slag. In one part of the bottom of that, you could see the wrinkly skin. That's also very diagnostic of slag. And also, if you look at it, it has a blobby, plasticky kind of flow. So I'm 100% confident that one is smelting slag, and those are my rationale. And slag is everywhere. It was used as roadbed. It was used as railroad bed. It was used as fill dirt. It's literally anywhere man has walked or woman has walked, except for Antarctica.
I am really proud of our crew, because we were able to do something that I guess is quite hard to do. We're special. We are a special group. We are able to separate our emotions, our wants, our desires, our pipe dreams, and really focus on facts. We did our best. If you have a preconceived idea and you're not going to listen to science, you might as well not sign up as a Patreon supporter. Other than that, if you're an open person and you're going to listen to science and not have your heart, your pipe dreams, your emotions, your dollar signs in the sky leading you down the Primrose path, you're going to be let down. Sorry to depress you at the end of the show. I hope you make it through the week. I know I will. Goodbye, guys.